welcome back. Today we're going to talk about Taylor-Maclaurin series, and what I want to do in this video is just briefly talk about how to obtain really basic Maclaurin series for e to the x and sine of x. And then in the next video we'll just do a couple of Taylor series for you guys to see as well. One thing that I will say about the Taylor-Maclaurin series is that the general formula for the Taylor series is written right here. And we're going to use this to do all of our problems that we need to do for these next couple of videos. And then the other thing I just want to make a point about is that the Maclaurin series is just a special type of Taylor series. So for Maclaurin series, we're just going to say that C is actually equal to 0. Alright? So we're going to come down here and we're going to look at the equation that we have here. So it's easy for me just to keep the equation up for you guys as we can see what's going to go on here. So I want to find the Maclaurin polynomial series of degree 5, all right, degree 5, for the function e to the x. So the two we're going to do today are going to be e to the x and sine of x. There's two more functions that you should know as a BC student for the BC exam. You should know how to do cosine of x and then 1 over 1 minus x. Those are the two other ones that you should be able to memorize and be able to write out very, very, very quickly. And you can find them anywhere, and they're done the exact same way that you'll see right here. So let's go ahead and talk about the first example here. So find the Maclaurin polynomial degree 5 for f of x equals e to the x. So the first thing that I want to acknowledge here is that in the very first term here, and I'm going to use x here, but it doesn't really matter for this. So in this case, Maclaurin series C is going to be equal to 0, right? And so for both of these examples, if C is equal to 0, then really you're just left with the x's in the parentheses, right? So Taylor series we'll do a little bit different stuff with, but that's it. So now you can see that we've now modified our Taylor series to become a Maclaurin series. So what we're going to do is we're going to go ahead and do a piece of n, or piece of x, is going to be equal to. And so we're going to basically now write a Maclaurin series for e to the x. And so this first term is just f of c, right? Well, f of c. Well, f of c is just really f of 0, right? Because we just talked about that c is actually 0. And so this is just going to be e to the 0 power, which is going to be equal to 1, right? So then I know that my first term here is going to be 1, all right? And then the next thing I'm going to do is I'm going to find the second term. Well, the second term is actually the first derivative. So when I tell students when I'm doing these problems for them, I say, okay, this is the initial term. And then I say this is our first real term, our second term, third term, just because everything about this is 1, right? It's the first derivative, it's raised to the first power, it's 1 factorial. This is the second derivative, raised to the squared, 2 factorial. So it's all about that. So we've done the initial term, or the 0th term, and then we go to the first term. And so back to this, well, our first derivative of this is just going to be e to the x value. And I know c and x are relative. Like I could do a c here, it doesn't really matter. But my first derivative really, in terms of x, is actually going to be e to the x. So then if I want to find f prime of 0 with my first derivative, again, I get 1. And this is the point where, for this example, I don't need to spend too much time on it. If I find the second derivative, it's still going to be e to the x. If I find the third derivative, it's going to be e to the x, right? So no matter what I'm doing for these problems, just f prime of n, x to the n, sorry, f of n, is also going to be equal to 1, right? They're all going to be equal to 1. So I know that this right here is 1. I know this right here is 1. I know this here is 1, and this is here is 1, right? So all I have to now do is just start writing my chain out. So if I look at this, this is 1, and it's going to be 1 times x over 1 factorial. 1 factorial is just 1. And then I'm going to go plus. And this again is 1, so this is going to be x squared over 2 factorial. And then same old, it's going to be 1 times x now cubed, so I'm in this term, over 3 factorial. And then x to the 4th over 4 factorial. And the question is asking me to find the degree of 5. So then I'm going to go one more and do x to the 5th over 5 factorial. And so this is the chain, this is the Maclaurin polynomial series for e to the x to the 5th degree. I want you guys to notice that also that there are 6 terms here. So this is the third term, if it asks you for that instead of degree, but it's our second degree. So it's also really important to acknowledge that that's what we're talking about. All right. And then the general form for this that we want to talk about is exactly, well, what's happening as we move along with this. So this is going to be our general term. So it's going to be infinity, and it's going to be n is equal to 0. And so you realize that if I go to x, it's going to be to the n power, right, to the n power, and then it's going to be n factorial. And the reason why students was like, why do you start at 0, not 1? Because remember, our first term, we have to get 1. And so we have to make this thing right here actually turn into 1. If we start at n equals 1, then we're going to be starting with this term right here. So sometimes it's n equals 0, sometimes it's equal to 1. So just always kind of verify that. And so this will be our general term for e to the x. Okay? That's e to the x. Okay, so let's go ahead and go on to our next equation. And I'm not going to use the formula up here for it. You know, we've kind of talked about it, so I'm just going to kind of just do it like we just did the first one. All right, so let's talk about it. All right, so sine of x is actually really cool to see what happens with this. And, you know, I told you guys before, the cosine of x is another one that you have to know. And this is exactly what we have to do. Okay, so the first thing we're going to do is we're going to, and I'm going to just, this is kind of like my work that's over here for these problems, and then I'm going to go ahead and write out our series over to the right in a little bit of time. But I'm going to get a little bit of stuff done first, because I know what I need to do. So I need f of 0, right? Because again, we're looking for a Maclaurin polynomial, so I know that c is going to be equal to 0, just like we talked about right here. And so I got to find out what sine of 0 is, all right? So the sine of 0 is going to be equal to 0. So our first term actually is 0, so we won't actually have it. And then the first thing we're going to do is we're going to find the derivative, the first derivative. So the first derivative of sine of x is just cosine of x. And then we're going to go ahead and find f prime of 0, which is just going to be the cosine of 0, which is going to be equal to 1. All right. And then we're going to find the second derivative. Well, the second derivative is the derivative of cosine of x, which is going to be negative sine of x. And then we're going to find what negative sine of 0 is, which is going to be 0. And then we're going to do this 2 more times, and you guys will clearly see what's happening with this pattern here. So then I'm going to do now the third derivative, and the third derivative is going to be negative cosine of x. And that's going to be f prime, third derivative, and that's going to be negative cosine of this, which is going to be negative 1. And then our fourth derivative is going to be the derivative of negative cosine, which is going to be sine of x, which we all know is 0 because we found it right here. So you guys will see that the cycle will pass, keep going. Therefore, the fifth derivative is going to be cosine of x, which is going to give you 1. This is the sixth derivative, the seventh derivative, and the eighth derivative. So we have all the work that we need to do to actually find our chain. So when we do this, we're going to do p of x. It's going to be equal to, well, remember, the first term is actually just 0. So I'm actually just going to leave that off. And so our second term, so this is going to be our second term right here. So this is the 1. So this is the number. I'm actually going to go back up one more second. So this is actually our f of c that I have marked out really ugly here. This is our f prime of c. That's going to be equal to 1. And so we're going to do 1, and we're going to do times x to the first power over 1 factorial. Right? So this is all about ones. And then our second term, right? So now we're going down here. Well, our second term is going to be 0. I will write this one out for you guys. So it's going to be 0 x squared over 2 factorial, right? And so this obviously will go to 0 initially. And then then I'm going to look at the next term. This is going to be the third derivative, negative 1. And then it's all about our 3's, right? It's all about 3's. And then our fourth term is going to be 0. So we're going to go ahead and put a 0 in front of that. Again, not needed. And then our fifth term is going to go right back to where we started before. So our fifth term would be the derivative of sine of x, which would be cosine of x. And so we're looking right back here for our fifth term. And so we're going to look at this. And so we'll go ahead and just simplify this, a little bit better for everyone. And say, all right, well, this is going to be piece of n, and this is for sine. And we go to x. And then we take the next term, which would be negative x cubed over 3 factorial. and then we're going to go ahead and do what is asked of us to find the degree of 5, which would be x to the 5th over 5 factorial. And I know it didn't ask for it, but I'm going to just, say for our purposes that if we were to continue on with this, it's just going to be alternating positive, negative, right? Odd exponents and factorials. So this would be yada, yada, yada. All right. So hopefully that makes sense to everyone. So these are our chains for both of our e to the x and then sine of x. So now if we want to look at the sine's general term, just like we did with e to the x, then we would go and look at what's going on with this. So we're going to go ahead and realize that our first term here, well, let's figure out what's happening first, and then we can figure out if it's n equals 1 or n equals 0. So we want to look at the fact that we are alternating our series, right? So we're going to go and do -1. Now, if we look at it, we'll go ahead and tell you right now it's going to be 0. So let's just do it that way. So then if we look at 0, we do this right here, right? So if n equals 0 for our very first term, this is actually going to become 1, right? And so then what's going to happen here is if we're looking at our function, what we can do for this one, when n equals 0, we want this term. When n equals 1, we want this term. So what we have learned here is we want 1, 3, 5, 7. And so a very easy representation of that is just 2 to the n plus 1, right? Where if we start at 0, then this just becomes 0, so we get x to the first. If this has to be 1, then it would be 2 times 1 plus 1, which is 3, and then again, and so on for this. And so since these are the same numbers, then our denominator is just going to be 2n plus 1 factorial. And so that's the general form for our sine function. Okay. So I hope this helps with you guys. The next video that I'm going to do for you, you can already see the example, the first example we're going to do, is what's happening when we do a Taylor series. And I think it's just awesome that I told you guys you have to know e to the x and sine of x. You also need to know cosine of x and 1 over 1 minus x. So I'm going to actually show you guys the chain for cosine of x when I do this example in the next video. So that's it for now. We'll talk to you guys in the next video.